Good morning, friends. This is again GB Shivakumar again. And see, actually, for the instrumentation engineers, actually, very important thing is data acquisition and communication systems, right? So they need to know what is the when data generated and how to transmit that, and then how to communicate to the receiver system, and to and fro communication is very much ensured, so which helps to do the efficient process monitoring and automations in the power plants, or not only power plants, any process oriented industries or manufacturing industries, discrete or it's a say repetitive or whatever it may be. But data acquisition, that is data logging and communication system, is very important, and the top management is looking, that is what actually the top management is implementing, these data acquisition systems and communication systems, right? So, in this kind of engineering, right, what it's a pure kind of digital communications and data processing, and so little bit of process-oriented knowledge is also required. So, in this area, the instrumentation engineer should know the data converters, digital to analog converters, implementing DAC functions, and then actually use of I can say use of ladder network, say especially for a PLC kind of thing, right? All the control systems and everything, and then bipolar coded digital to analog converters, resolutions, settling times. I mean, settling time for the devices, and response times, transient errors. What I mean, in the meantime, what happens at in the instantaneous or transient mishappenings that will cause an error, right? Actually, the instrument response, and even actually the worker is doing something on the equipment, actually it will cause errors. So those kind of things actually can be tracked by the data loggers, and then sent to the top management or the control room person, so that they will avoid mistakes in the future coming days, right? That is important. So A to D converters are this analog to digital converters, parallel analog to digital converters, feedback AD, that is AD means analog to digital, okay. Parallel analog, feedback analog, RAM type A to D, dual slope AD, successive approximation. Successive approximation AD, and resolution conversion times, and then comparison of analog to digital conversion techniques. Typical ICs for digital to analog, or vice versa, analog to digital conversions. Isolation amplifiers, so to avoid noise prone areas, and hazardous things, right? Actually, so we need to have isolation amplifiers for any electronic circuit. So those things for the data trending and everything, data logging, that is very important. And data acquisition systems comprising of sampling, oriented theorem, sampling and digitalizing, aliasing. So sample aliasing means a sample and hold circuits. Then practical implementation of sampling and digitalizing, review of programmable peripherals, so IO devices, and then definition. The instrumentation engineer should know that the each instrument definitions and operation design and need for the implementing data acquisition systems in a particular process. So how to interface AC and D to A, or D to A to D with the microprocessors or PCs, multiplex channels, so which is used for multiplex channel operations, right? And then ground returns, microprocessors or PC based data acquisition systems, and then review of analog and digital communication systems and techniques, and then multiplexing, FDM, frequency data distribution mixing, and time division multiplexing, frequency division multiplexing, that is also called FDM and TDM, right? So data communications, transmission lines and digital signals, and frequency components of pulse waveforms, practical line interfaces, how to measure the pulse waveforms, how to measure the practical line interfaces in circuits, and their capabilities, limitations, and serial synchronous communications protocols, and then related hardwares, UART, Universal standard protocols, right? UARTCs and so Intel 80, I mean 80 to 51A software UARTCs, base band interfaces, standard 20 milliamps current loop interfaces, EIE interface standards, and then we have I mean, instrumentation engineers should know the communication standards also. So about the communication network, telephone networks, PC per XT, network hierarchy, and switching transmission characteristics of the network, and local loop and signaling, modems, then serial synchronous communications, data coding methods, the error detection in the communication networks, right? And then corrections, and I can say encryptions, data encryptions, LAN, local area networks, topology, protocol, standard Ethernet and ORCnet configuration specifications, and then actually they should know the fiber optic communication systems, building blocks, their building blocks, light sources, light emitting diodes and laser diodes, optical fibers and related types, and dispersion, and how to measure the dispersion losses, optical fiber cables, how to avoid the loss in optical fiber transmissions, how to prevent the interference, and then I can say optical couplers and decouplers, connectors, decoders, and pin and APD detectors, and then role of pin and APD, role of optical fiber in data acquisition and communication. So transmitters, receivers, and repeaters, how to do satellite communication, how to do the Wi-Fi related networks, how to handle the. I mean, first thing for the data acquisition and communication engineer should, I mean, instrument. I mean, this can be. I mean, actually, in this field, actually, the ECE or E&I or Triple E or electronics guys can. I mean, instrumentation control, right? Actually, all these persons are eligible to work in this field. So the main aim is to how to I mean, they should know how the particular device is handling, how when the error will happen. Based on their experience, they need to troubleshoot, and based on the data logging or data trending, they need to analyze the faults and try to fix all the problem as soon as possible without without disturbing the function process parameters or process oriented thing. Say the mechanical engineer or a field electrical engineer can look for the trending and data to fix up problems, right, in their machines and say breakers and everything. So they need to this trending data logging can help them to analyze a problem at what time and when, at which time, and if during any change of circuit breakers this happens, or any transient is created, any short happen, so everything grounding happen, everything they can able to analyze using the data link. That is what actually the data acquisition and communication system is very important in the process power plant, especially in low dispatch sensors and power plant. Actually, definitely they need this data acquisition and communication system. That is what we are using, DCs, PLC, or SCADA, all these things, right? And if you want to know more about this data acquisition system and communication systems, we have standard textbooks, that is GB Clyton Data Converters, published by Macmillan Press Limited 1982, and then Paul Bates Practical Digital and Data Communication, Prentice Hall 1987. And then we have a lot of references. We have Douglas B. Hall Microprocessor and Interfacing, McGraw-Hill Limited 1986, and Wayne Thomsey Advanced Electronic Communication Systems, and Kaiser Optical Fiber Communication Systems, McGraw-Hill Limited 1983. These books are really useful. I hope the details I have given is very useful. Thanks friends, this is GV Shivakumar signing off.